Do you know that the lipstick sitting in the handbag of millions of women worldwide requires 8 weeks from concept to finished product, passes through 43 precision-controlled steps, and contains ingredients sourced from 5 different continents? Behind that seductive red color lies an $18 billion industry, where a single mistake can waste $50,000 in minutes. Grab yourself a cup of coffee and settle in, because in the next few minutes, I'm going to take you inside a world where ancient beauty secrets meet pharmaceutical-grade precision, where that $3 tube in your local drugstore demands the same quality control as medications. But before we begin, hit that subscribe button and turn on notifications, because what you're about to discover will completely change how you see that little tube of color you apply every morning. Let me introduce you to batch number L7293, produced at the Chromatic Beauty facility in Newark, New Jersey. This batch will become 15,000 lipsticks in shade Ruby Passion, and its journey actually began 8 weeks ago when cosmetic chemist Dr. Sarah Mitchell submitted her formula for approval. 2 weeks of stability testing followed, where sample lipsticks sat in chambers cycling between -5 and 55 degrees Celsius, simulating everything from frozen shipping containers to Arizona summer heat. Only after passing these tests did the procurement team place orders for ingredients, and here's where the global supply chain kicks in. The journey of our batch's main ingredient begins in the remote apiaries of New Zealand's South Island, where beekeeper James Chen tends to 53,000 hives scattered across pristine meadows. These aren't ordinary beehives. They produce some of the purest beeswax in the world, a golden substance that has been the foundation of cosmetics for over 5,000 years. Each hive produces approximately 2 pounds of wax per year, and it takes the lifetime work of 8 worker bees to create just 1 teaspoon. On March 15th, James harvested the spring wax, carefully melting it at exactly 80 degrees Celsius to preserve its natural properties, then filtering it through silk screens to remove any impurities. This wax was packed in food-grade containers and shipped via temperature-controlled freight, arriving in Newark exactly 14 days later. While that shipment crossed the Pacific, another critical component was being prepared 7,000 miles away. In the northeastern Brazilian state of Ceará, workers were harvesting carnauba wax from palm trees during the peak dry season. These remarkable trees, known locally as the Tree of Life, can live for 200 years, and each tree produces only about 2 pounds of wax annually. The young leaves are collected, sun-dried for 3 days, then beaten to release the wax flakes. This process has remained virtually unchanged for 3 centuries. For our batch L7293, 280 pounds of carnauba wax were processed, packed, and shipped, taking 19 days to clear customs and reach New Jersey. Simultaneously, in the Sonoran Desert of Arizona, jojoba seeds were being cold-pressed to extract the liquid wax ester that gives lipstick its smooth glide. The Preston family farm, operating since 1992, supplied 40 gallons of certified organic jojoba oil. From Gujarat, India, came 120 gallons of castor oil, pressed from seeds and triple-filtered to pharmaceutical standards. The Indian supplier, Bharat Castor Industries, has a 6-week lead time from order to delivery. But the most complex component, the pigments, required the longest preparation time. In a specialized facility outside Munich, Germany, chemists at Chromatic Pigments GmbH spent 3 weeks creating the exact shade of Ruby Passion. Iron oxides were synthesized in ultra-pure conditions, ground to particles measuring just 20 microns, 3,000 times thinner than a human hair, then blended in precise ratios. Quality control technician Klaus Hoffman, who has worked there for 19 years, personally verified each batch under 6 different lighting conditions before approval. The pigment shipment, valued at $12,000 for just 80 pounds, traveled via air freight with climate control, arriving in Newark on week 5. By week 6, all ingredients for batch L7293 had finally converged at the Newark facility. Now the real transformation could begin. At 6:30 on a Tuesday morning, production supervisor Maria Rodriguez unlocks the compounding room, a space the size of 3 basketball courts filled with gleaming stainless steel tanks. Maria has been with Chromatic Beauty for 16 years, and she's never lost a batch. She knows that the next 8 hours will determine whether batch L7293 becomes 15,000 perfect lipsticks or $50,000 of waste to be melted down and reprocessed. Her first task is verifying the ingredient staging area. Each raw material container has a QR code linking to its certificate of analysis, showing purity tests, microbial counts, and origin verification. The system won't allow production to start if even one ingredient falls outside specifications. Today, everything checks green. the beeswax from New Zealand, the carnauba from Brazil, the oils from Arizona and India, and the precious pigments from Germany, all cleared for processing. At exactly 700 hours, as Maria calls it, the melting phase begins. Two technicians load 280 pounds of beeswax and 140 pounds of carnauba wax into Tank Alpha, a 500-gallon vessel with computer-controlled heating elements embedded in its walls. The target temperature is 85 degrees Celsius, and the margin for error is just 1 degree. Temperature sensors take readings 40 times per second, making automatic adjustments via an algorithm that cost the company $80,000 to develop. These waxes will take 90 minutes to completely liquefy. Rush it, and you create hotspots that degrade the wax structure. Too slow, and you waste energy and fall behind schedule. While the waxes melt, a parallel process unfolds in Tank Beta. The oils, castor, jojoba, vitamin E, and several proprietary additives are measured with precision that would impress a pharmacist. We're talking accuracy to within 0.01%. A single gram too much or too little in a 300-gallon batch can alter the lipstick's melting point enough to cause customer complaints. These oils heat to 70 degrees Celsius, deliberately cooler than the waxes because vitamin E breaks down above 75 degrees, losing its antioxidant properties. Here's where Maria's experience becomes critical. At 9:15, both tanks reach target temperature, but the viscosity readings on Tank Alpha show slightly higher resistance than normal. The computer says it's within acceptable range, but Maria has seen this before. She orders an additional 15 minutes of mixing. Later testing will prove she was right. The batch would have developed microscopic wax crystals that could make the lipstick feel grainy. Now comes the most technically demanding step: pigment incorporation. The 80 pounds of ruby passion pigment must be dispersed so thoroughly that not a single clump remains. This happens in a machine called a 3-roll mill, a beast of engineering that cost $220,000 and was shipped from Switzerland. 3 horizontal steel rollers, each weighing 400 pounds, spin at different speeds. The gaps between them measure just 5 microns, about 1/10 the diameter of a human hair. As the pigment paste gets pulled through these gaps, the shearing force is immense, about 15,000 pounds per square inch, enough to pulverize any particle that tries to stay together. Technician David Park monitors the mill's output. He's been doing this for 11 years, and he can tell by the paste's texture if something's wrong. The first pass takes 45 minutes. He samples the output, spreads it on glass, and examines it under a microscope at 400 times magnification. He's looking for any particle larger than 25 microns. He finds 3, not acceptable. The paste goes through 2 more passes, another 90 minutes of processing. On the third inspection, it's perfect. 0 detectable particles. This paste will create that flawless, smooth color women expect. At precisely 12:45, the pigment paste is pumped into the main compounding tank, where 300 gallons of melted waxes and oils are waiting. The temperature is carefully adjusted to 78 degrees Celsius, the sweet spot where everything flows smoothly but nothing degrades. Industrial mixers kick in, their motors humming at 1,750 RPM. The mixing phase runs for 3 hours, and this is not wasted time. Engineers discovered through painful trial and error that mixing for less than 2.5 hours creates microscopic air bubbles that won't appear until the lipstick is 2 weeks old, when customers start reporting breakage. The company learned this lesson the hard way in 2018, when they lost $400,000, recalling a batch that was mixed for only 90 minutes. Now, the mixing timer is hardwired. It cannot be overridden, even by Maria. At 3:50 p.m., Batch L7293 is finally ready for molding. The liquid is pumped through heated stainless steel pipes to the molding room, where precision-machined aluminum molds wait in long rows. Each mold contains 350 individual cavities shaped exactly like a lipstick bullet. These molds were manufactured in Osaka, Japan, milled to tolerances of 0.05 millimeters. Each mold cost $8,000 and will produce approximately 5 million lipsticks before microscopic wear forces replacement. The molten lipstick mixture fills each cavity in 2.3 seconds. Sensors using laser measurement verify that each cavity is filled to within 0.2 millimeters of specification. Any mold position that fails triggers an automatic rejection, and that cavity is purged and refilled. Out of 350 positions per mold, an average of 2 fail on first fill. The molds immediately enter a cooling tunnel where temperature drops from 75 degrees to 5 degrees Celsius over exactly 20 minutes. This gradual cooling is critical. Cool too fast, and internal stress cracks form that won't show up until the lipstick has been in someone's purse for 3 weeks. That's when customer service gets angry calls. Quality Control Inspector Robert Chen has worked this line for 22 years, and he's seen everything that can go wrong. As the lipsticks emerge from cooling, robotic arms equipped with vacuum grippers extract them from the molds. The vacuum pressure must be exactly 12 pounds per square inch, 11 pounds, and the lipstick might slip, 13 pounds, and you leave a mark. These German-made robots process 500 lipsticks per minute with a failure rate of 0.03%. But Robert still pulls random samples every 30 minutes for manual inspection. Now comes the flaming step, a process that looks almost magical. Each lipstick rotates through a precisely calibrated propane flame, burning at exactly 50 degrees Celsius for 0.3 seconds. This brief kiss of heat melts just the outermost 20 microns of surface, creating that mirror-smooth, glossy finish and sealing any microscopic surface imperfections. The technique was invented in 1950, and despite decades of research, nobody has found a better method. It's still done the old way, because the old way works perfectly. For Batch L7293, 50 sample lipsticks are pulled for destructive testing. Yes, these lipsticks will never reach a customer. They're sacrificed for quality assurance. A machine applies increasing pressure until each lipstick breaks. The reading must fall between 500 and 900 grams of force. Today's average is 720 grams. Perfect. Another set goes into a heat chamber programmed to cycle between -10 and 55 degrees Celsius for 72 hours straight. This simulates months of real-world conditions compressed into 3 days. If even one sample softens, bends, or shows stress cracks, the entire batch of 15,000 lipsticks gets rejected and melted down for reprocessing. It happens about twice a year, and it's heartbreaking every time. The lipsticks that pass all tests move to final assembly. The tubes, manufactured in Shenzhen, China, and shipped in sterile packaging, arrive at the line. Automated systems running at 300 units per minute. Insert each lipstick into its tube with exactly 8 millimeters exposed. The twist mechanism must click smoothly through 12 complete rotations, each rotation extending the lipstick precisely 2 millimeters. Laser printers mark each tube with invisible batch codes that allow complete traceability. Sandra Williams has worked the packaging line for 9 years. She watches as boxes are printed, folded, and sealed at 400 per minute. Each boxed lipstick passes through 5 inspection stations, checking for proper sealing, correct label placement, and package integrity. Metal detectors scan for any contamination. Weight sensors verify each package contains exactly one lipstick weighing between 12 and 13 grams. The rejection rate is kept below 0.1%, but in a production run of 15,000, that's still 15 units that don't make it. So what does this 8-week journey cost? Raw materials for Batch L7293 total $18,000, coming out to $1.20 per lipstick. Add manufacturing, labor, energy, quality control, and packaging, and you're at $2.40 per unit. These will sell wholesale to retailers at $4.50, who'll price them at $8.99 on the shelf. High-end brands using the same facilities with premium ingredients and luxury packaging can reach production costs of $5 to $7, but sell for $25 to $45 retail. The global lipstick market moves $18 billion annually. American women alone purchase 900 million tubes every year. The average woman uses between 4 and 7 lipsticks annually. And now you understand why that number might actually be low. When you know the 8-week supply chain, the pharmaceutical-grade quality control, the 43 precision steps where one mistake wastes thousands of dollars, suddenly that little tube represents an achievement of global logistics and chemical engineering. Batch L7293, all 15,000 units. Shipped to distributors on week 8. Most will be on store shelves within 10 days. And somewhere, a woman will pick up tube number 7216, test it on her hand, smile at the perfect shade of ruby passion, and have no idea about James the beekeeper in New Zealand, Klaus the pigment inspector in Germany, Maria, who saved the batch with 15 extra minutes of mixing, or Robert, who's been protecting quality for 22 years. But now you do. If this journey fascinated you, smash that subscribe button, because next week we're going inside the perfume factory where a single bottle requires ingredients from 23 countries and a master perfumer who spent 15 years learning to identify 3,000 individual scents. Thanks for watching, and I'll see you in the next one.